As we move into chapter 8, working with proportions, let's look at this first question. Solve the proportion round to 4 significant digits if necessary. There are some rules for dealing with significant digits. So one of the rules is if you're dealing with like whole numbers, you ignore anything that's on the front end or on the back end. But if there's zeros in the middle, you would count them. So all non-zeros and any zeros contained between the non-zero digits, we count. So if we're dealing with whole numbers, this example here, all the digits are considered significant. Now, if you're dealing with decimals, leading zeros don't count. So if we look at decimals, when I talk about significant digits, these leading zeros will not count. So this is only 2 significant digits. If I'm dealing with decimals, trailing zeros do count. So notice that the front zeros don't count, but these trailing zeros do count. So notice how there's 4 significant digits in this example because the trailing zeros are important in this example. So that would be considered 4 significant digits, even though there's, 7 digits, or even this zero here, there's 8 digits present. Only the last 4 here are considered significant. And if you're dealing with whole numbers again, trailing zeros may or may not count if there is no decimal point. So we go with the most conservative answer. So if I'm dealing with whole numbers, trailing zeros aren't counted. So only the front numbers are counted in this case. So 2 significant digits. Now there could be considered up to 6 significant digits, but if we're trying to be on the conservative side, only the front digits count, the trailing zeros do not count. So when I do this example, if we have zeros involved, we have to pay attention where those zeros fall in the problem, whether we count them or not. So in solving proportion, one of the rules you've learned is in a proportion, a true proportion, the cross products must also be equal. So one of the strategies to solve this equation is we are allowed to kind of cross multiply to solve this proportion. Notice how the variable's in the bottom as well. So one thing to pick up on is x plus 4 cannot equal 0. So if I solve that by subtracting 4 on both sides, what we pick up on is x cannot equal a negative 4, because if x is a negative 4, that creates a 0 in the denominator. And again, it doesn't make sense to divide by 0. So this is one of those what they call extraneous solutions that we would have to throw out. So it doesn't ask for that in this problem. So hopefully our answer is not negative 4. So as we solve this problem, so, really what we're looking for is what makes the top a 2 and what makes the bottom a 3. If you can figure that out, you got the solution as well. But you can also use cross multiplication to help kind of manipulate this as well. So this is going to be 3 times the quantity x minus 6. This is going to be 2 times the quantity x plus 4. So when we cross multiply, that x minus 6 is going to get multiplied by the 3, and this x plus 4 is going to get multiplied by the 2. So math looks like this. So again, to remove the parentheses, we have to use distributive property. So the 3 has to go through the parentheses. This turns into 3x minus 18. On the other side, we have to distribute the 2 through the parentheses. We multiply through the parentheses, and that becomes 2x plus 8. And as you learned, since the variable is on both sides of the equation, we pick on what I refer to as the little guy. So the coefficient of 2 is smaller than the coefficient of 3. So to get the variable on the same side of the equation, we can subtract a 2x on both sides. This allows us to get x minus 18 is equal to 8. And if we now get rid of the constant, which is this negative 18, the opposite of a negative 18 is a positive 18. So do the opposite there, if you will. Add 18. That'll create what we'll call a zero pair. So that will drop out of the problem. X equals then 8 plus 18 would be 26. So 26 would be the answer. So if we check this, 26 minus 6 over 26 plus 4, does that equal 2/3? So that's going to be on the top, 20, and on the bottom would be a 30. Does 20/30 is that the same thing as 2/3? Remember, fractions can be reduced if there's a common divisor, such that if you divide the top and bottom by 10, you can drop those zeros and you would indeed get 2/3 equals 2/3. So it does check out. So notice how that problem is a little more complicated than it looks. And cross multiplying was a good strategy to find the solution. So the solution set would be 26. So there is an answer to the equation. It would be 26.